Hi, good evening. Today I want to record a Build with AI talk in English, so I can time myself before I deliver a Cantonese talk in Hong Kong on January 24th, 2026. So my topic is Gemini 3 updates. So my agenda is Gemini 3 models. What is new in Gemini 3? It is because Gemini 3 has new capabilities or new value that Gemini 2.5 doesn't have. And I wrote some Colab examples to use Nano Banana Pro and Gemini 3 Flash Preview to show like how to use them. And it is also a learning process for me to get familiar with these new models. So Gemini 3 is the latest model as of January 2026. This is the model card of Gemini 3 Pro Preview. So it has caching, file search, structured output, URL context, batch API, code execution, function calling, search grounding, and thinking. And thinking has a new value, and there is like change in structure output, etc. So the inputs can support text, image, video, audio, and PDF. The output is text. So this is the model card of Gemini 3 Fresh Preview. And this is the model card of Gemini 3 Pro Image Preview. And this is the actual name of Nano Banana Pro. So Nano Banana Pro is the nickname of this model. And search grounding and thinking are new in this model. In Nano Banana, which is a Gemini 2.5 Flash image, search grounding and thinking are not supported. Yeah. So the inputs can be image or text or image and text. So the output is image and text. So this is the cost. I mean the pricing and the context window of all the models. So Gemini 3 Flash Preview is cheaper than Gemini 3 Pro Preview. Well, these models are in preview status, so don't use them in production. Like use Gemini 2.5 Flash or Gemini 2.5 Pro in production until Gemini 3 is GA. That's my advice. Next, I want to talk about the new changes in Gemini 3. Thinking level, media resolution, thought signature are new. Structure output and tools are not new, but Gemini 3 supports structure output with tools. In Gemini 2.5, I don't think it is possible. So thinking level, maximum level of processing before a response is made. So in Gemini 2.5, thinking config was introduced, and this configuration has at least these properties, like include thought, which is a Boolean, which tells the model to provide thought summaries or not. Is it thinking? I don't remember it's called thought budget or thinking budget. It is the number of tokens that the LLM allowed to do the reasoning and provide the thinking summary, so user knows how the model approaches the task and uses its best ability to tackle it. In Gemini 3.0, a new property is added to the thinking config. It is called thinking level. It has two possible values, low and high, and the default value is high. Media resolution, multimodal visual processing. So improve the model's ability to read text and identify small details in multi-modal inputs. So it has global or individual settings. Supported formats are image, PDFs, and videos. So this is the recommended settings for different media types. So for images, the recommended setting is high. For PDFs, the setting recommended is a medium. For video, use low and medium for most cases. Use high when the video has dense text or small details that need to be captured within video frames. Thought signature. Maintain a reasoning context in multi-turn. This thing is like an encrypted value, and I've never seen it. I've never used it. It's because the Gen AI SDK already handles thought signature. So if you use TypeScript, Go, Python, and languages that Gen AI SDK supports, you don't have to worry about anything. Let the Gen AI SDK handle the signatures like on your behalf. Structured output with a tool or tools. It's supported in Gemini 3. In Gemini 2.5, I was told error. I was told that this can lead to error. So I can specify response min type response underscore JSON underscore schema and tools in a generate content config. For example, I can use Google search tool to look up real-time data on external sources such as websites and YouTube videos. I can also use URL context and Google search tools together, so I can force LLM to use URL context as my primary source and use a Google search tool to look up the information when the provided URLs do not have the information that I demand. So in order to run my Colab examples, please sign up Vertex AI in Express mode. My friend Cyrus, who is also an AI GDE in Hong Kong, made like a fantastic like Cantonese YouTube video that talks about Vertex AI in Express mode in details. There are like 3 examples to describe the different use cases of Gemini 3 Flash Preview model. So the first example uses the URL context and Google search tools to look up 2025 and 2026 stats of an English Premier player. So the response is a structured output with the player statistics. Sorry. So the second example is about image understanding. So I use the model to compare 2 images, and the model answer whether or not the 2 persons look similar, and give a score and some evidence to support its answer. So example 3 is about video understanding. So I asked the model to watch my video and answer some questions about it. And when the model replied, it also needs to provide the segments to support its answer. Go map tool and got error. So it makes a lot of sense now, like after like reading the model card. Google Map tool is not supported. Neither is the URL context tool. So this Gemini 3 Pro image preview model is ideal to generate infographic, tutorials, and weather forecasts. So this is the tool like array, and it has one tool which is the Google search tool. The name of the model is Gemini 3 Pro image preview. So I provide a text prompt to generate an image. Thinking config of Nano Banana Pro doesn't support thinking level. I tried and I got an error. So I passed true to include thoughts and 512 tokens to the thinking budget so I can see the thinking summary. And if I want to see the thinking summary, I need to include text to the response modalities array. So tools has Google search tool, image config is optional. So if I want to specify the aspect ratio and the image resolution, I provide the values to the image option. Otherwise, the default values are used. Thinking mode, reasoning of LLM mode. Okay. So it is enabled by default in Gemini 3. So if I provide thinking config to Gemini 2.5 Flash image model, also known as Nano Banana, I will receive an error. Well, I tried and I got an error, so I learned my lesson. Thought summary. So part.thought is true and part.test is non-summary. Then we know this is the thinking summary or the thought summary, and we can print it out if we are interested in the reasoning that the LLM used just to generate the final image. So thought tokens count is always non-zero because thinking mode is enabled by default. Well, it also means the total token is the sum of the input token, the output token, and the thought tokens. Better text rendering, multilingual, able to render traditional Chinese characters correctly. I tried, and I actually saw like correct traditional Chinese characters in my image, and I was so happy I almost cried. And the default language is English, so if we want to display a different language in the image, we have to mention it in the prompt. And Nano Banana Pro is also good at translating text from one language to another in an image. I think I tried and I was able to translate from English to traditional Chinese in my case. So this is a prompt that I used in one of my Colab examples. So please display Beitao and Yangmingshan National Park in traditional Chinese, and Nano Banana Pro generate like the image and the tradition and the locations in traditional Chinese. Aspect ratio and image resolution. More aspect ratio, new image resolution. So possible values are 1K, 2K, and 4K. And I don't know if it is obvious to you. K must be in uppercase, and the default value is 1K. So this is like the sample code. My test prompt, I upload 2 images, and the image size is 2K. The aspect ratio is 3:2. The temperature is 0.5, and I think I asked Nano Banana Pro to use these 2 images to generate like some imaginary offsprings of for the couple. This is my Colab example, like imaginary offspring. So I have 2 like images. I need to make sure that one of them is a male and another image is a female. They are a couple, and I use these images and ask the model to generate a new images with the imaginary offsprings. Oh, yeah. So this is the end of my talk. I should leave 5 5 minutes for Q&A and 5 minutes to run one or two demos that I mentioned in the previous slide. So this is the first example where I use the URL context tool and the Google search tool to find the player stat. So this is the structure output with name, meta status, current club, possession, goal assist, total shot, total passes, dribbles, appearances, total tackles, and minute played. The URLs that I provide doesn't have dribble information, so I wonder how LLM find the answer. Maybe it has internal knowledge, or it uses the Google search tool to find the data, or it deep reads the URL or URLs until it finds the information about the player's dribbles. So get URL context metadata is a function that verifies the URL context tool is triggered. So when the tool is triggered, the URL is retrieved, and the URL retrieval status is success. And get player stat function is responsible for constructing the prompt and asking Gemini 3 Flash preview model to return an object that complies to the schema of player stats. So these are the URLs from www.premierleague.com. This is a prompt to get the player stat of a player from the URL. So I provide the URLs, I provide the player name. This is the JSON response with name, meta status, current club is professional player, verification status, position, goal assist, total shots, total passes, dribble, appearances, total tackles, and minute played. So I pass the test prompt to the model. The response mean type is application JSON. Response JSON schema is player stat. The tools are type.url context and type.google search. So let's try to get the player stat of Bruno Fernandes. He's a midfielder, and his current club is Man United. So 5 goals, 8 assists, 47 shots, 126 passes, 30 tackles. So okay. So all the URLs are fetched successfully. So let's click a few links to verify the answer. So Man United, position midfielder, 30 shots. So where does 47 comes from? Okay. So 18 appearances, 5 goals, 8 assists. Let me see. Anything else? Passes 1026. Total tackles 30. I want to find out. Minutes played 1538. So let's see. 1538 minutes played, total tackles 30, appearances 18, 1026 total passes, 5 goals, 8 assists, dribbles. So 20. So I guess the URL context tool is working, and I am going to stop the demo here. The next example is image understanding, where I have 2 images and I ask Gemini three flash preview model to compare them and return a score of similarity and list key similarities and key differences. So the core function is analyze facial images that accept two file name, and this is the prompt to analyze two images and use the scoring rubric to determine how similar or dissimilar two persons are. So the JSON object has a similarity score, which is a percentage, and some similarities and some differences. So the model name is Gemini 3 Flash Preview. The test prompt for comparison, two E9 data, which is two images. The response mean type is JSON. The response JSON schema is facial analysis. Media resolution is high based on the recommended setting. Even though the default value of the thinking level is high, I set it explicitly here. So thinking config equals to types dot thinking config, and thinking level equals to thinking level dot high, and I get a JSON object. I return it and use the print result function to print the percentage, similarities, and differences. So let's see. So facial analysis is a very simple model. It has a percentage, which is an int, similarity, which is a list of string, and differences, which is also a list of string. So let's run the demo. Should be here. So I want to compare Ashley Olsen and Mary Kate Olsen. The Olsen twins are identical twins. And in this case, I compare like two images that are exactly the same. So I expect the score to be 100%. Okay. So the Olsen twins are 88% similar. So similarities, identical eye shade, matching facial proportion, nearly identical nasal architecture. Okay. Consistent lip shape. Differences. Person A display more pronounced buccal hollowing, sunken cheeks. Person B has a slightly softer, more rounded mandibular line compared to the sharper jawline of person A. Subtle variation in the width of the nasal something nostril are visible upon close inspection. Let's see. Okay, sunken cheeks, softer line, different shape of nostril. Okay. Percentage 100. Identical facial geometry and bone structure, except match of facial features including eyes, nose, and mouth, matching hair growth patterns and hairline. Differences, none. The images are identical copies. Yeah. So image understanding is very simple. So this is the end of my demo. So my last example is video understanding, where I pass a custom interval of my public YouTube URL to Gemini 3 to watch the video and answer some questions, and I used the response as my previous answer, and then pass the video to Gemini to generate 3 follow-up questions to encourage deeper learning. So let's run the Colab and then look at the code. So this is my video, and the start offset is 22 minutes and 49 seconds. The end offset is 26 minutes and 40 seconds. So I asked Gemini what I was saying in this video clip, and provide the top 3 most relevant segments to support the answer. So and then I use the previous answer and the video and the metadata to generate 3 questions. So and in here I output the follow-up analysis, the follow-up question, the question type, and the reason. Okay. So I talk about the use of Gemini 2.5 Flash for audio generation. Like how I created a buffer, how I converted a source node to a destination of audio context, and the importance of using the ng on destroy lifecycle hook for cleaning up sources. So 3 segments and the reason. Okay. Follow-up analysis. The analysis focus on the specific implementation of the web audio API within the Angular service shown. So 3 questions. A technical question, the reason given, a visual question, and a concept question. So let's look at the code. So the first core function is ask my video, and the model is Gemini 3 Flash preview. The parts are the question and the video URL, and the config has low media resolution. Response mean type is application JSON, and response JSON schema is grounded video answer. And I got a JSON object back. And then in the get follow-up questions function, this is my prompt that uses the previous answer to generate 3 follow-up questions. And the JSON object has a follow-up analysis, has 3 questions. The first question is a technical question, the second question is a visual question, the third question is a conceptual question. And I have a system prompt, which is this one, and 2 parts, the same video URL and the previous answer, and the model return a different structure output, and that's it. So these are the demos that I want to show, and I will do more rehearsal so that I can deliver a smooth talk on January 24th. So thank you and have a good day. Bye-bye.